This is my pre-algebra course. Today we're going to learn how to graph linear equations, and also we're going to graph inequalities. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. Now, before we learn how to graph linear equations and inequalities, we have to figure out how to plot points or graph points. In a previous class, we learned how to graph points in one dimension. So when we graphed in one dimension, we just drew one line and then made our numbers. But when you graph in two dimensions, you have to draw two lines, as you see here, a horizontal line and a vertical line. And the horizontal line is almost always called the x-axis, and the vertical line is called the y-axis. Now you can name those axes whatever you want to name them, but in math they're typically called the x-axis and y-axis. Sometimes it's time, t for time, and d for distance. It just depends on what you're graphing. So here's some points that we're going to graph for practice. So first, let's plot the A point. This point is named A. So what this means is we're going to go out 1 to the right, so around here, 1 to the right, and maybe I should get my highlighter, 1 to the right, and then 2 up. So 1, and then 1, 2, and then we're going to plot that point. So right there. So that's point A, and I can go ahead and label that point. So I graphed the point, and it's also called a coordinate. I graphed it, and then I labeled it. And the colors are going to help us too. So now let's go to the green. So again, the first number is always the horizontal movement. That's movement in this direction. And the second point is always the second value is always the vertical movement. So now we'll do B. So B says go out 3, 1, 2, 3, and then down, because it's -1, down 1. So that point would be here, and we'll put a B next to it. So that's how this works. It's pretty easy. So the purple C, we have a -1, so we'll go -1 out this way, and then up 1. So that's our purple point. And you don't always have to put the letters above, but in this case it's probably best. And then D is -2, -2, so we go to the left and then down. So that point will be here. And so the negatives are always to the left and down, and the positives are to the right and up. So now we'll get our pink or our orange color. 0, 0, that would be you're not moving anywhere. You're just staying at what's called the origin. So just so you know, this orange point is called the origin. We should go ahead and label it though. So that's the origin. You're going to want to remember that. So that's a special point. And then the purple. Let's get a purple pen here. Dark purple. -3, 0 would be here. And that's G. And then H is gray. 0, -2, that would be down here. And then I is a black pen. Let me get my black pen out. -3, -3. That would be all the way down to the left. So that's down here. So that's how you plot points. As you can see, it's not very difficult. It's pretty easy. So why don't you try? Go ahead and pause the video and see if you can plot these points. Or actually, you don't really need to pause it, I guess. But I'll just wait for you to plot the first 2 or 3 points, and then and then I'll start to catch up with you. So go ahead and see if you can plot those points. Draw the graph on paper, or if you have a digital notebook, draw the graph. It doesn't have to be it doesn't have to be perfect. It doesn't have to be precise. Just draw the basic graph and make sure that your divisions are evenly spaced. And draw your 6, 6, -6, and -6, and be sure to name your axes and label the axes X and Y, and then go ahead and try to plot those points, and be sure to write the letters next to them. So when you come back, we'll check your answers. All right, we're back. So -6, 2 should be here, and 4, -4 is down here, and 0, -2, that would be here, and -4, 6 is here, and 2, 2 is here, and 6, 0 will be over here, and -3, 5. So G, H, and I, they're a little bit more difficult because they're not going to land on the divisions or the markings. So 5 would be, so here's -2 is here, and then -3 is halfway between these two marks. So you go out here and then 5 up, so here. So that should be about there. Actually, no, we need to go a little higher. I'm sorry about that. Should be here. And we'll label that G, and H is -5, -3. So -5, -3 should be down here. That looks correct. And then the I is 1, 5, so that would be here. So if that's your graph, if you did that correctly, good job. Again, to the right and up are the positive directions, and to the left and down are the negative directions. So as you can see, graphing is fairly easy. It's no big deal. So that now that we know how to plot points, we're going to go ahead and graph linear equations. So this is a linear equation, and what we're going to do is we're going to find 2 points, and then we're going to connect the dots, and that's it. That's pretty much what we're doing today. It's going to be really easy. So here's how we do this. So this is going to be our first point. Now we're going to have our second point over here, and I'm going to show you how to make a table also. We don't really need a table, but they're so common to use tables. It's so common to use tables, and I'm going to just go ahead and show you what they look like. So for the first point, what we're going to do is we're going to choose any x value you want, but it has to be within this window. Notice we have +3 and -3, so it has to be somewhere 3 or less than 3. And in this case, it actually has to be less than 3, because if you add 3 and 1, you get 4, and that goes out of our window. So I'm gonna the easiest points to choose are usually 0, 1, or -1. So I'm going to choose 0 for x, and then I'm going to plug in 0 for x. So I plugged in 0 here. And then I'm going to figure out what y equals if x is 0. So 0 plus 1 is 1. So y equals 1. So I'm going to go ahead and write what x equals, just to be absolutely clear. So we're going to let x equal 0. And then we're going to plug that in to the equation. And again, you can see that if x is 0, then y is 1. So let's go ahead and write what's called an ordered pair. So we'll put parentheses, and the first number, x is 0 and y is 1. So this is the ordered pairs that we were using previously. So then in the table, I just want to show you how to use a table. You don't really need one, but I want to show you how it works. So the x value is 0, and the y value is then 1. So now we're going to plot that point. And it goes, I'm going to probably should use colors. So it goes right here. All right, so that's the first point. Now we're going to plot the second point. So I'm going to let x equal 1 for the second point. And then I'm going to plug in 1 to x in this equation. So then it would be 1 plus 1 is 2. So we let the x value be 1, and the y value we figured out is 2. So then we're going to plot that point, and it goes right here. So then we just connect the dots. And that's our line. We have to be careful not to go too far out, though. You want to just fill your window. So in case you're wondering, this is the window here. You see the purple line that I'm drawing? This is your window. So you want to make the line fill that entire window. What a lot of students will do is they will just connect the dots like so, and they'll say, I'm done. Well, no, you can't do that. You got to fill your entire window. So make sure that you do that. All right, so that's the first graph. That's what the line looks like. No big deal. But when you do this in your homework, I want you to show this work. I want you to be very clear about what's going on there. Whoops, I think that should be a 0 there. And you don't really have to write this table if you don't want to. I just want to show you what it looks like. So now we go on to the next problem. We'll do a couple more of these before you try one on your own. So again, we're going to do we're going to do 2 points, and we're going to do a table. So for the first point, we're going to let x, actually in this case, it'd be easier to plug in y first, because x is isolated. X is by itself on one side of the equation, so we're going to plug in y first. Sometimes it's better to plug in x first, sometimes it's better to plug in y first. But whatever variable is isolated, you plug in a number for the other variable, and that's gonna be the easiest way to do it. So let's let y be 0, because 0 is usually the easiest point to choose. And if y is 0, then x equals 3 times 0, because remember, when you have a letter next to a number, that means you're multiplying the number by the letter. So y is 0, so 3 times 0 is 0. So if x is 0, then y is 0 also. So that's our first point, 0, 0. So I'm going to go ahead and plot that. And I got to put that in my table here, 0, 0. And now I'm going to let y equal, we chose 1 in the previous problem for the second value, so I'm going to choose -1. So then x is equal to 3 times -1, and 3 times -1 is -3. So the point is -3, -1. So notice how I'm writing the x value first. You always write the x value, the horizontal value first in the ordered pair. That's extremely important. The y value, the vertical always goes is on the second number, and the x value, the horizontal movement is always on the first value in the ordered pair. So -3, -1 is down here. And I'm going to go ahead and connect those dots. And it takes some practice to get these lines straight. It doesn't have to be perfect. This isn't an art class. But you kind of have to look at the entire line as you're graphing. All right, so that's the second graph. So let's do another one of these. Also, I want to explain what's going on here. So we've demonstrated how to do this, but I just want you to be aware that when you graph this equation, if you pick a million different points, they're all going to be on this line. So there might be a point here, there might be a point here, here, here. The more you graph, they're all going to be on this line. So that's why we draw the line through those 2 points, as the line represents all of the points that satisfy these equations. But you don't really have to know that. You just have to graph the equation, connect the dots, and make sure that the line fills the window. So now let's say that it'll be easier to choose y first because x is solved for. So let's let y equal 0. And if y equals 0, then x is equal to 0 minus 3 because I'm using this equation. And x is equal to -3. Therefore, the coordinate is -3, 0. And let's let y equal +1. And again, not all points are going to work here. Because if you go out of your window, if you find a point up here in this region, it might work, but it's out of your window, so you can't choose that point. If I choose y equals 1, then x is equal to 1 minus 3, which is -2. So our coordinate is -2, 1. All right, so -3, 0, -2, 1. So first point is there, and second point is there. So we'll connect the dots. And you don't have to use colors. So if you don't have colors, don't worry about it. All right. Let's try one more of these before you try one on your own. Again, to make a line, you only need 2 points. We could graph a million different points, but we just don't need that many. So in this case, y is solved for, y is isolated, so that means it's easier to plug in an x value first. So again, I'm going to choose x equals 0. So if x equals 0, then y is equal to 0 over -2, and any fraction with 0 in the numerator is just going to be 0. So the point is 0, 0. The x value is 0, the y value is 0. So I'm going to plot that point and draw it in my table here. And for the next value, I'm going to, now this is important. You could choose 1, but then we'd end up with a fraction. We don't want to deal with a fraction if we don't have to. So we have to choose a special x value so that we don't get a fraction. There's a lot of different x values we could choose, but the x value has to be less than 3 because if it's bigger than 3, obviously it's going to go out of our window. So the values we can choose are 0, which we already chose. That works. That doesn't give us a fraction. But the only other 2 values we can choose are -2 and +2. So I'm going to choose +2. So you have to be really careful about that when you have fractions. If you don't want to get a fraction, you have to be clever about what value you choose. So then y is equal to 2 over negative 2, which is negative 1. So the coordinate is 2, negative 1, which is right here. So again, we're plugging in an x value. We're choosing any x value we want to choose, and then we're finding what y equals. And we'll connect the dots and do your best to make the line straight. If your line is a little bit off, that's okay. But if you draw a line like this, then that's incorrect. Don't do that. It's got to be fairly straight. All right, so hopefully you're getting the hang of this now. And I got to put that other point there, 2, negative 1. So now it's time for you to try. Go ahead and attempt number 5, and you're going to have to draw your graph. You're going to have to get used to drawing your axes. So draw your axes, and you can use the same divisions that I'm using. And you're going to have to label your axes. You're going to have to label. You don't have to label all of the marks. Notice that I don't label these inner marks. You see, you don't really have to. If I know that there are 1, 2, 3 marks, and they're evenly spaced, which they always should be evenly spaced, and if I know that this one is 3, then I have to assume that this one is 2 and this one is 1. Okay, that's just common sense. So you don't have to label every single mark, but you do have to label the axes. Teachers, like I said, teachers just love to take off points for not labeling your axes. So choose 2 points and plot those points and connect the dots. And when you come back, we'll do it together. All right, we're back. So I'm going to choose x is solved for. X is isolated. So we're going to choose a y value first. That's the easiest way to do it. And I'm going to choose 0. And if y is equal to 0, then x is equal to 2. So the point is 2, 0. And I'm going to choose y is equal to 1. So if y is equal to 1, then x is equal to 3, based on our equation over here. And the point is 3, 1. So 2, 0, 3, 1, and connect the dots. So if you got that graph, good job. All right, try number 6, and when you come back, we'll do it together. All right, we're back. Y is isolated, so that means it's better to choose a x value. I'm going to choose 0 for x. And y must be equal to negative 2 times 0. And we're using parentheses for multiplication like we learned in a previous class. So anything times 0 is 0. So the point is 0, 0. Right there. All right, now I'm going to choose, and by the way, you can choose, your choices for x may be different than my choices. But as long as the line is still in the same place, then your answer is going to be correct. So now let's choose x equals 1. So then y equals negative 2. And connect the dots. And so if your line is like so, good job. Remember, you have to fill the window. A lot of students will kind of get lazy and they'll draw the line up to there. That's not good enough. You have to fill that window. So if you got that answer, if you got that graph, good job. All right. So for number 7, we have a fraction, so be careful. You have to choose certain values of y so that we don't end up with a fraction. Now you can use a fraction. There's nothing wrong with using a fraction. It just makes it more difficult to graph. So try number 7, and when you come back, we'll do it together. All right, we're back. So we're going to let y equal 0. And again, because x is isolated, it's better to choose y values first. So if x is 0 and y is 0, so that's that point there. And now I'm going to let y, I can let y be 3 or negative 3. So let's choose negative 3 this time. Or excuse me, that should be a y. So let y equal negative 3. You may have chosen positive 3. That's okay. So negative 3 divided by 3 is negative 1. So the point is negative 1, negative 3. So we'll put that in our table. And the point goes here. Connect the dots. And there you go. So if that was your graph, good job. All right, so why don't you try number 8, and when you come back, we'll do it together. All right, we're back. Again, you don't have to use these tables over here. I'm just showing you what they look like because you're going to see those very often in your math education. And these points, they can also be called coordinates. Now, y is by itself, so that means it's easier to choose the x value first. So we'll choose 0 for the x value as usual. And if x is 0, then y is negative 1. So the point is, or the coordinate is 0, negative 1. So that's right here. And let's choose positive 1 for x now. So y equals 1 minus 1, which is 0. And so our point is 1, 0, which is here. And we'll connect the dots. So if you got that graph, good job. All right, so this problem is slightly different. It's really just a much easier graph. So go ahead and attempt number 9. The important thing to understand is that when the x and y values are all going to be the same. So try number 9, see if you can do it on your own, and when you come back, we'll do it together. All right, we're back. So it doesn't really matter which one we choose. I'll just choose x is equal to 0. So if x is equal to 0, then y is also equal to 0. So the point is 0, 0. The x and y values have to be the same, so if x is 0, then y must be 0. And if we choose 1 for x, then y must equal 1 also. So the point is 1, 1. So we have 0, 0, 1, 1 in our table there. 0, 0, and 1, 1. And connect those dots. All right. So if you got that graph, good job. All right, so now we're going to get a little more complicated. In a previous course, we learned how to evaluate algebraic expressions. And we also learned that sometimes those algebraic expressions have names. Well, this would be the algebraic expression that we're going to evaluate, and the name would be y. So let me demonstrate how this works. This is the same thing we were just doing, except the equation is a little bit more complicated, that's all. So again, we're going to choose 2 points. So for the first point, I'll choose x equals 0. That's always a good choice, or usually a good choice. So if x equals 0, we plug that in there. And we have to evaluate this algebraic expression. So we have to do order of operations. We have parentheses, which means multiplication. So 2 times 0 is 0. And then 0 plus 1 is 1. So if x equals 0, then y must be 1. So the point is 0, 1. And again, it's very common for students to mix up these values. The x value always comes first in the ordered pair, and the y value always comes second in the ordered pair. Don't mix those up, or else you're going to get really confused. So plot that point, it goes right there. Now we'll choose, just to mix it up, I'll choose a negative 1. So if x is negative 1, we plug that into the equation. And order of operations tells us to multiply 2 times negative 1, which is negative 2. And then you add negative 2 and 1 to get negative 1. So our coordinate is negative 1, negative 1. Put that in our table. Negative 1 would be about here. And lastly, connect the dots. And there you go. So this is the same thing we were doing. It's just we're doing more complicated equations now. But you, if you did all the homework from my classes on evaluating algebraic expressions, then this should be really easy for you. So let's do a couple more of these before you try some on your own. All right, now x is isolated. So that means we should plug in a y value first. So if y equals 0, and we have a fraction here, so we have to be careful. If y equals 0, then solve for x. 0 divided by 2 is 0, so we have 1 minus 0. And 1 minus 0 is 1, so the point is 1, 0. Again, the x value goes first. The x value always goes first, then the y value. So 1, 0 would be here. All right, now we're going to choose y equals, we have to be careful about this. We have to choose 2. If we choose, well, I guess we could choose negative 2 also. So 2 or negative 2 are the only ones that we can choose. Actually, you know, we could choose 4 also, or negative 4. Anyway, so let's choose 2. So that it's more than one answer. There's more than one value you can choose. But again, you can't choose 100 for y, because that would go out of our window. It's not wrong, it's just out of our window. So plug in 2 for y. And 2 divided by 2 is 1, and 1 minus 1 is 0. So if x is 0, or if y is 2, then x is 0. All right, 0, 2 would be here, and connect those dots. And there you go. So we'll do maybe one more of these before you try one on your own. Y is isolated, so let's plug in the x value first. Let's say x is, now here's a situation where if we plug in 0, we're going to get -4 for y, but we can't plot that on our coordinate system. So we're going to have to choose something different. Let's try choosing 1 for x. And if x equals 1, then y is equal to -4 plus 3 times 1. Remember, when a letter and a number are next to each other, that means multiplication. So then y is equal to 3 times 1 is 3. And -4 plus 3 is -1. So the coordinate is 1, -1. Which is here. And let's try x is equal to, now I'd like to try -1, but we can't do that because I can see it's going to be -7, and that's out. So let's try 2 for x. So again, if you plot a point and it's out of your window, you can either change the scale of your window. That's perfectly fine. Or you can just plot another point. So if x is 2, then y is equal to -4 plus 3 times 2. Three times 2 is 6. -4 plus 6 is 2. And so if x is 2, then y is 2 also. So that's here. And connect those dots. And usually the reason I'm using green and red is there's just a lot of contrast with green and red. That's probably why stoplights are always green and red. It's easier to see them. Alright, so let's see here. You know what, let's try one more together before you try some on your own. Alright, so x is isolated, so we should plug in the y value first. Let's say y is equal to 0. Then x is equal to -0 over 4 minus 1. 0 over 4 is equal to 0. And -0, that's really just 0. And 0 minus 1 is -1. So the point is -1, 0. So that's here. Now we'll choose, we have to be careful because this is a fraction. I think 4 will work. So let's let y equal 4. And if y is equal to 4, then x is equal to the following expression. 4 divided by 4 is 1, so that would be -1 minus 1. -1 minus 1 is -2. So the point is -2, 4. And I just noticed that I can't do that, so that was a lot of work for no reason. My point is not on the window. -2, 4, that would be, you go out 2 to here and then up 4, and that would be up here. So that's out of my window. So I was so busy doing my math here that I didn't even realize that's not going to work. So if that happens to you, that's okay. Just go back and fix it. So we can't do 4. Let's see here. So this is a case where it looks like we might have to change our scale. I didn't see it at first, but it looks like we're going to have to change the scale. So you see these 3's here. I'm going to erase those 3's on our graph. I'm erasing the 3's, and I'm going to replace them with 6's. So now we can fit those easy points in. Another way to do it is just to use a fraction. But in this case, I'm going to just go ahead and change that scale. So each jump would be 2. 1, 2, 3, 4, 5, 6. All right, so now I have to graph -1, 0. So -1, 0 would be here now. So -2, 4 would be here. So those are the 2 points. Connect the dots. And there you go. So I'll put that math back in there. So y is equal to 4. All right, so now it's time for you to try. Go ahead and try 14, and when you come back, we'll do it together. All right, we're back. So y is isolated, so we should try x values first. So I'm going to try x is equal to 0. So y must be 1. Then I'm going to try x is equal to -1. Actually, I think I'm going to try +1. So I get 1, -1. 0, 1, 1, -1. So plot those 2 points, and again, you may have different coordinates that you graphed. That's okay as long as the line looks correct. Then you got the right answer. All right. So if you did that correctly, good job. Now try number 15, but be careful. We have a fraction, so you got to be careful about the numbers you choose. You can use fractions, but it just makes it more difficult. So try number 15, and when you come back, we'll do it together. All right, we're back. So plot your 2 points so you can connect the dots. So x is isolated, so I'm going to plug in the y value first. Now I will choose, looks like we have the same situation here where we may have to change the scale, but this time instead of changing the scale, I'm just going to use a fraction. So I'm going to plug in, let's see, I'm going to plug in 3/4, wait no, I'm going to plug in 3. So then we have 3/4 minus 1 is equal to x. And that would be 3/4 minus 4/4, because 1 is the same thing as 4/4. And 3/4 minus 4/4 is -1/4. So our coordinate, which you can also call a point, is -1/4, 3. So again, it's not wrong to have a fraction. It's just more difficult to have to graph that, to have to graph a fraction. All right, so we're ready to. Let me write that in my table first. So I'll go ahead and graph that. -1, 0 is here, and -1/4 is about that far out. -1/4, 3 would be up here, right on top of the 3, so I'm going to have to write the 3 on this side. All right, and then connect the dots. So if you got that graph, good job. Again, you may have chosen to change the scale, but the graph should look relatively the same. All right, so why don't you try number 16, and when you come back, we'll do it together. All right, we're back. Y is isolated, so we should plug in x first. That'll make it easier. -1, 0, and 1 are usually the easiest points, or the easiest values to use. mark that point. 0, 2 is here. Then I'm going to choose, I have to choose 1. I have to choose 1. If I choose -1, it's going to be out of the window. So I'm going to choose 1 for x. And I get y is equal to 0. So 1, 0 will be here, and connect the dots. You might be wondering why this stuff is important. Well, you're going to have an entire chapter in the next course after this one that's just lines. And you're going to be studying lines in your math courses pretty much until you graduate from school, or whatever curriculum you're using. You don't necessarily have to go to school, and I certainly don't recommend it. All right, so on to number 17. If you got that graph, good job. Try number 17, and when you come back, we'll do it together. All right, we're back. So let's see, y is isolated, so it's better to plug in x. So I'm going to try the good old 0. So we have 0, -3 is that point. So that'll be down here. Now I'm going to try to plug in, I'm going to have to plug in a negative number, else we're going to go off our scale. So I'm going to try x equals -1. If you try to plug in +1, you may have noticed it's going off the scale. So -1. -5 times -1 is +5. 5 minus 3 is 2. So if x is -1, then y is 2. That will be there. So if you got that line, good job. All right, so for number 18, we have a slightly different situation here. Notice the 100. That means that it's going to be extremely difficult to graph this unless we change the scale. So I'm going to take these 300s, or excuse me, these 3s, and I'm going to change them to 300s. So I'm going to erase those on the graph. And I'm going to write 300 here, and -300. So each one of these divisions is 100. So let's graph this one together. You can do the next one. So y is isolated, so it's better to choose x. So we'll choose 0. 0 is going to work in this case. So y is then equal to 100 minus 3 times 0. 3 times 0 is 0. So if x is 0, then y is equal to 100. So that's going to be pretty easy to graph. That's going to be about here. Now I'm going to choose, normally we would choose -1, 0, or 1, but those values are going to be, they're going to make it really difficult to graph the point. So I'm going to have to choose, I'm going to choose 100. So x is equal to 100. So now y is equal to 100 minus 3 times 100. So 3 times 100 is -300. Or 3 times -3, -3 times 100 is -300. And then 100 minus 300 is -200. So that would be about here on the graph. And connect those dots. And I'm going to write that 300 on the other side so my line can reach the end of the window. You want to get in the habit of filling your window completely there. All right. So sometimes you do have to change the scale significantly on these. That's okay. You can use any scale you want to. So why don't you try one of those problems? Try 19, and when you come back, we'll do it together. All right, we're back. So y is isolated again. In most of these problems that we've been doing, y is always isolated. So, or y is isolated in most of them. So that means it's going to be easier to choose for x, and we can choose 0 for this one. Negative 2 times 0 is 0. 0 minus 100 is negative 100. So if x is 0, then y is negative 100. So that will be here. And I forgot to change my scale, though. I got to change that scale to 300s instead of 3s. So now let's choose. We got to be careful that we don't go off the scale. I think we can choose positive 100. And again, if you're having trouble going off the scale, that's okay. Just keep trying numbers until you figure out which one works. Negative 2 times 100 is negative 200. And negative 200 minus 100 is negative 300. So the point is 100, comma, negative 300. Which is down here. Connect the dots. All right, I went a little bit out of the window there. That's okay. It's going to be roughly correct. All right, so if you got that answer, if you got that graph, good job. So now try number 20, and when you come back, we'll do it together. All right, we're back. So again, we need to graph 2 points, and then we're going to connect the dots. That's how you do all this stuff. That's how you graph lines. So now x is isolated in this problem. So now it would be better to plug in y first. It just makes it easier. So, but don't confuse your x and y value when you write these ordered pairs, though. The x always goes first. $200 would be there, and I have to change my scale again. So now we'll let y equal, let's see here, we have to be careful about this. I think 100 is actually going to work. So negative 3 times 100 is negative 300. And Negative 300 plus 200 is negative 100. So x is negative 100 and y is 100. So that would be, whoops, that would be up here. And connect the dots. Let me make that dot bigger. And there you go. So if you got that graph, good job. All right, so 21. Nothing special about 21, I guess. Actually, we're going to have to change the scale on it, but other than that, it's the same type of problem. So go ahead and try 21, and when you come back, we'll do it together. All right, we're back. So y is isolated, so we're going to plug in the x value first. So y is negative 8. So you can see we have to change the scale. It's not going to fit. So now let's plug in now let's see if we chose 3. If we chose 3, that would work. If we chose 2, that would not work. If we chose 5, negative 1, yeah, it looks like we're going to have to change the scale. There might be a way to do it, but I'm not seeing it. So let's try x is equal to, let's see, 3. Then we have 3 and negative 2 is the coordinate. 3, negative 2, and 0, negative 8. So let's plot those points. First we have to change the scale though. So 1, 2, 3, 4, 5, we're going to need, I'm going to do 4, 8, 12. So I'm going to make this 12. So now each division is 4. So 4, 8, 12. So we got 0, negative 8. That'll be here. And 3, negative 2. That would be about here. And connect the dots. So if you got that answer, good job. All right, on to number 22. This is another problem where you might have to change the scale on your graph. So go ahead and try 22, and when you come back, we'll do it together. All right, we're back. So x is by itself on one side of the equation, so we'll plug in the y values first. So 5, 0. And we'll worry about graphing it later. We're going to have to change the scale. So let's try, we have a fraction, so we have to be careful. Let's try 10. Or you could try negative 10. And x is equal to 1 plus 5. 10 over 10 is 1. 1 plus 5 is 6. So our point is 6, 10. So you can see that we definitely need to change the scale. So let's erase these 3's on the graph. And we're going to have to choose, let's see, I'm going to do 12's again. And then 5, 0. Let's see, I put that in my table. 5, 0 would be about here. And 6, 10 would be about here. Actually be about halfway up there, halfway between those. All right, and connect the dots. It's a pretty steep line you can see there. And there you go. So if that was your graph, good job. All right, so for 23, something's going to change here. It's the same principle. We're going to do the same exact thing, except the difference is that one of the variables is not isolated. In other words, one of the variables is not by itself on one side of the equation. Now, x on this problem was by itself. But here we have x and y on the same side of the equation. So that means that we're actually going to have to perform some algebra to actually figure out what the values are. But again, it's the same procedure, so let's get started here. So I'm going to choose x is equal to 0. And I don't really think we have to perform algebra on this one because this one's fairly easy. We can probably just do this in our head. So if x is 0, then we have 0 plus y is equal to 1. So you tell me, what does y have to be? Well, it's pretty obvious. Y has to be 1. So that's our first point, 0, 1. And let's let x equal 1. Then we have 1 plus y is equal to 1. And technically here, I mean, you don't really need to perform the algebra, but what you would do is just subtract 1 from both sides, and you would get, obviously, 0. Y has to be 0. So we had to perform a little bit of algebra there, technically. But you could probably just figure that out just by looking at the equation. So 1, 0 is that point. So we have 0, 1, and we have 1, 0. Connect the dots. So again, the only difference with that problem is that the equation is a little bit more difficult to work with because one of the variables is not solved for. So why don't you try number 24 and see if you can do that without performing a lot of algebra, because we're going to get to some problems where you definitely are going to have to perform quite a bit of algebra. So attempt that problem, and when you come back, we'll do it together. All right, we're back. So we don't have a variable that's solved for. I'm going to try plugging in an x value first. So let's try plugging in 0 for x. Because a variable is not solved for, it doesn't really matter if you choose x or y. Just choose whichever one you think might work better. So x is 0, and then this one we didn't really have to perform much algebra because we know y minus 0 is just y, and so y must be 2. So the point is 0, 2. Let's try 1 for x. Now for this point we might have to perform some actual algebra. So y minus 1 is equal to 2. So again, that's a one-step algebraic equation. You don't really need to use the algebra. You can probably do it in your head. I'm not going to force you to do that algebra. But you can see just by looking at the equation, y obviously has to be 3. But technically you would add 1 to both sides, and you'd get y is equal to 3. So the point is 1, 3. 0, 2, and 1, 3. Connect those dots. So if you got that graph, good job. So here we have another situation where no variable is solved for. So go ahead and attempt that problem, and when you come back, we'll do it together. All right, we're back. All right, so we'll just choose x is equal to 0. So 2 times 0 plus y is equal to 1. Again, this doesn't really require a huge amount of algebra. So 2 times 0 is 0. 0 plus y is just y, and y is equal to 1. So the point is 0, 1. All right, now let's choose 1 for x. So 2 times 1 is 2. And subtract 2 from both sides, and we get y is equal to -1. Or you could just figure that out by just looking at the equation. So our point is 1, -1. 0, 1, and 1, -1. Connect the dots. So if that was your graph, good job. All right, so again, you're going to have to get creative here. So attempt number 26. We have a fraction, so be careful. And when you come back, we'll do it together. All right, we're back. I'm going to plug in 0 for x. And therefore, 0 over 3 is equal to 0. Y minus 0 is y. And y is 4. So if x is 0, y is 4. And let's try, I'm going to try 3 for x. Again, we have to be careful because we don't want to deal with a fraction if we don't have to. And I can see that that's not going to work. It's going to be out of our scale. So I want to try to stay in our scale if I can. So I'm going to try -3 so I don't have to change my scale. So that's going to make that a double negative. So y minus -3 over 3. That looks right. A double negative becomes positive. And of course, 3 over 3 is just 1. And subtract 1 from both sides, and you get y is equal to 3. So the point is -3, 3. You know what, I just realized this is out of our scale anyway, so I'm going to have to change the scale regardless. So we'll just make that 6 and 6, and -6 and -6. So I guess trying to stay in the scale there was futile. 0, 4, and -3, 3. Is about there. And connect the dots. The line was kind of getting crooked there. Again, these are supposed to be lines, but I'm not that great. I don't have a steady hand. All right, so if you got that graph for 26, good job. That was more of a challenging problem. For 27, you can go ahead and attempt that problem. And let's put a divider here. Just remember that when you have a negative in front of a variable, that's just assumed to be -1 times the variable. So go ahead and attempt that problem, and when you come back, we'll do it together. All right, we're back. Let's see, I'm going to choose, I think it'd be better to plug in x values. So I'm going to choose 0 for x. And then we get -0 plus y is equal to 2. And therefore y obviously is 2. So our point is 0, 2. And let's plug in 1 for x. And we get -1 plus y is equal to 2. And then to solve for y, you just add 1 to both sides, and you get y is equal to 3. So the point is 1, 3. And again, we have to isolate the y, so we have to get rid of that 1. So we have to add 1 to both sides. We learned how to do that in previous classes. So this should be really easy algebra for you at this point. 0, 2, 1, 3. And connect the dots. So if you got that graph, good job. All right. So we have a fraction on number 28, so be careful. Go ahead and try number 28. When you come back, we'll do it together. All right, we're back. And I'm going to plug in the y value first. So let's let y equal 0. Then we have 0 over -3 plus x equals 1. 0 plus x is equal to 1, which means x obviously must be 1. And let's try 3 for y now. Again, you could try to plug in x, but that would be much more difficult to have to deal with that. So notice I'm always choosing the easy way out. If I plug in y values first, it makes it a lot easier for us. If I plug in an x value first, then we're going to have to do a two-step algebraic equation. So I'm going to plug in 3 for y. Add 1 to both sides, and you get x is equal to 2. So the point is 2, 3. So we got 1, 0, and 2, 3. Connect the dots. So we got that graph. Good job. All right. So 29, we're getting more and more challenging here. So go ahead and try 29. When you come back, we'll do it together. All right, we're back. So it's going to be probably a lot easier to plug in the y's first. If you plug in x's, you're going to have a two-step equation. So I'm going to plug in 0 for y. And we get -x minus 4 times 0 equals 2. 4 times 0 is 0. And -x minus 0 is just -x. So at this point, we have -x equals 2. But remember, that's just assumed to be -1 times x is equal to 2. So I'm just going to divide both sides by -1. And we get x is equal to -2. So our point is -2, 0. Now, I'm not showing that division. Normally, we would show a fraction sign and divide it by -1, divide both sides by -1. But in this particular class, I'm not going to make you show every single step because it would get pretty tedious after a while. So now, let's see here. I'm going to choose -1 for y because I want to try to stay in our scale, in our window. Negative x minus 4 times negative 1 equals 2. And negative 4 times negative 1 is positive 4. And subtract 4 from both sides. And divide both sides by negative 1. And x is equal to 2. Let me just double check that. Yep, that's correct. So our point is 2 and negative 1. All right, connect the dots. So if that was your graph, good job. That's kind of a challenging one because we have so many negatives there. We have a negative here and a negative here. So if you didn't do all the homework from your previous classes, you're going to be hurting right now. All right, we have another problem with a bunch of negatives, so go ahead and try number 30. And when you come back, we'll do it together. All right, we're back. So plug in y equals 0. Again, we can plug in the x values first, but that would make things a lot harder. And I'm actually going to plug in an x value first just to show you what you would have to do in order to solve it. So I'm going to plug in 0 for x, and it's going to be a lot harder now. So I just want to show you what's going on if you don't choose wisely. So now we end up with negative y over 2 minus 3 equals 0. But this is not easy. This is a two-step algebraic problem. So we have to add 3 to both sides. And that gets rid of this 3 and puts a 3 on the other side. Then we have to multiply both sides by negative 2. And we end up with negative 6. So you see all those steps that we had to do? Whereas if I just plugged in 0 for y, instead of plugging in an x value first, then that would have been a lot easier. So we'll do that in the next time. But if you don't choose wisely, you're going to have to do a multi-step algebraic equation. Just double checking that. That looks correct. 0, negative 6. So let's plug in 0 for y instead of choosing the 0 for x. So let y equals 0, and we have negative 0 over 2 minus 3 is equal to x. And 0 over 2 is just 0, and the negative doesn't really affect anything. And then we have 0 minus 3 is minus 3, or negative 3, and x is equal to negative 3. So our point is negative 3, 0. And I forgot to put the point over here. That would be 0, negative 6. All right, so negative 3, 0. And I just realized that because I have that negative 6 in one of my values in the ordered pairs, I'm going to have to make a new scale. So we'll make it 6. Zero, negative 6 is here, and negative 3, 0. That would be here. Because again, each one of these divisions is 2, so it would be 2, 4, 6. So this would be 2 here, and then we have to go one more to get to 3. And connect those dots. So if this was your general graph, good job. Try your best to fill that window. All right, on to number 31. So 31, we're getting even more difficult here. This is about the most difficult problem we're going to do. And the reason this is difficult is because it's difficult. It's hard to find. It's hard to avoid fractions. So let's go ahead and do this one together. So we'll plug in 0 for x. Then we have 2 times 0 plus 3y equals 1. 2 times 0 is 0. And the 0 just goes away. We're left with 3y equals 1. That's a one-step equation. So we're going to divide both sides by 3. I'm not going to make you show that, but then we end up with 1/3. So because we have 1/3, we can't use this scale. Well, actually, we can use it. It's just not going to be easy because our points are going to be too close to the origin. And remember, this is the origin here. So we're going to have to change the scale, but let's go ahead and find the other point first. So let's let y equal 0 for this other point. They have 2x plus 3 times 0 equals 1. And we're left with 2x is equal to 1, and divide both sides by 2, and you get 1/2. So this point over here is 0, 1/3. And this point is 1/2, 0. So I'm just double checking those. It looks correct. So what I'm going to do is I'm going to change the scale because it's going to be really difficult to graph. In fact, let me go ahead and try to graph it just to show you why it would be difficult. 1/2 and 0, that would be, this is 1 here, so 1/2 would be going out this much. And I guess that one's not too bad to graph. And then so that's 1/2, 0, and then 0, 1/3 would be about here. So you can do it, it's just the points are really close together. So what I'm going to do is try to space these out by changing the scale of the graph. So I'm going to change it so the scale is, so this is 1 here. And then each one of these divisions would be 1/3. So 1/3, 2/3, 3/3. 3/3 is 1. So 0, 1/3 is going to be here. And 1/2, 0, that's going to be, 1/2 would be halfway between this distance, which is about here. Roughly there. So the 1/2, 0 would be about there. So again, it just spaces the dots out so we can graph this easier. So most of the problems are going to be fairly easy, but you will get a couple of these in the homework where it's where you're going to have to deal with fractions. Yeah, why don't you try 32 on your own, and when you come back, we'll do it together. All right, we're back. So I'm going to let x equal 0. And then we get y is equal to -3/2 using all the algebra that we learned in previous classes. So now I'm going to let y equal 0. I just want to stick with the zeros because I know I'm not going to get whole numbers anyway, so I can just choose the easiest numbers. So then plug in 0 for y. Divide both sides by -4, and we get +3/4. So we have 0, -3/2 for one coordinate, and 3/4, 0 for the other coordinate. So let me just double check those. Looks correct. So I'm going to change my scale. I'm going to make the same scale that we did before. Actually, I'm going to make this 3/2. And so 0, -3/2 would be here. And then 3/4, 0. That's going to be kind of hard to tell where that is, but this is 1/2, and then 2/2, and then 3/2. So the midpoint there is 1. This is 1 whole because 2/2, 2 over 2 is 1. So 3/4 should be somewhere between 1 and 1/2. So we'll just put it there. It doesn't really matter exactly where it is, as long as it's in the general region. You don't have to get your ruler out with these graphs or anything. Don't bust out your ruler. It's just a waste of time. Just make sure the graph is good enough. It doesn't have to be perfect. So if you got that graph, good job. That was a challenging problem. So let's go on to 33. Let's do 33 together. Let's let x be 0. And then I'm going to skip forward here, so we have 5 over 3. Y is 5 over 3. And let's let y equal 0 for the next point. Again, this is not easy stuff. We're getting fractions. So -x over 2 plus 3 times 0 equals 5. 3 times 0 is 0. And so -x over 2 equals 5. We're going to multiply both sides by -2. We have to get rid of the 2 and the negative. So you have to multiply both sides by -2. And you get -10. So our point is -10, 0. Alright, so we're going to have to definitely change the scale there. So 1, 2, 3, 4, 5, 6. Let's make that 12. So we have 0 and 5/3. 5/3, in order to graph that, we're going to have to change it to a mixed number. We got 3/2 in the previous problem. We didn't change it to a mixed number, but it's going to help us to change it to a mixed number when you're graphing. So how many times does 3 go into 5? It goes 1 time. What's left over? 5 minus 3 is 2, and then the denominator stays the same. So 1 2/3. We learned how to do that in the previous class. So there is some cases where using mixed numbers does help. So 0 and 1 2/3. So that would be about. Let me plug that into our table. And then -10, 0. So 0, 1 2/3. That would be about here. And -10, 0 would be about here. You have to be really careful that you graph this properly. So the line is it's not very steep. It's kind of hard to graph it. My line is not very good there, but it's good enough. So we're kind of running out of time here. So I'm going to go ahead and skip to the next section. The rest of the problems you can pretty much do on your own. I don't really need to tell you. You got the main idea. So now we're going to go to graphing linear inequalities. So what we're going to do here is pretty much the same that we're doing, the same thing that we were doing with graphing equations. But there's going to be a slight twist. So you're going to graph the line. These are linear inequalities, so it's going to be a line. So we need 2 points to graph a line. And so we'll choose, y is isolated, so we're going back to some easier ones here. So we can choose a value for x. That's going to make it easy. So y is less than or equal to 4 plus 0, because we chose 0 for x. Therefore, y is equal to 4. We can just consider y equal to 4. So the point is 0, 4. So we're going to go ahead and plot that point. But I just realized that we went out of our window there. So I'm going to have to change the window. You can either go back and do a different point, or you can change the window. It's up to you. So I'm going to make this 6. All right, so 0, 4 would be here. And now let's try -2 for x. That's going to be a good one. And then y is going to be 2. So we have -2 and 2. -2 and 2. So that'll be about here. All right, so now we're going to connect those dots. And so at this point, everything that we've done is the same thing that we did for graphing linear equations. But now there's a little twist at the end here. Because this is an inequality, the points on the line are not the only points that are going to work in that expression here, or in this expression. Because that expression is not an equation, it's an inequality. So there's going to be a lot more points, not just the points on the line, but there are going to be a lot of other points that work in this expression. It turns out that, well, let me just show you how to do this here. So let's choose a point. You can choose any point. Just make sure the point is nowhere near the line. So it can be all the way over here, or it can be over here, but don't get anywhere close to that line. So I'm going to choose 0, 0. That's an easy point to choose. So then I'm going to plug in 0, 0 to this equation. So I'm going to plug in 0 for y. So we'll title this check. I'm going to plug in 0 for y and 0 for x. So I'm just plugging in a y value and an x value, a random y value and an x value. And then I'm going to see if that point works in this inequality. So we have 0 is less than or equal to 4 plus 0. And then that simplifies to 0 is less than or equal to 4. So I want to ask you, is it true? Is it true that 0 is less than or equal to 4? And of course, that is true. 0 is less than or equal to 4. So what that means is that because our point, our test point was here, that means that all these values to the right of this line are going to work in that inequality. The values on the line and the values that they're shaded in here, they're all going to work. So you want to shade in all of this part in the window, and you don't have to shade in everything, but make sure most of the region is kind of shaded in there. And what you're going to do with your pencil is you can kind of just scribble in like this. That's good enough. So let me just use a different color there. I'm just going to use the shaded. So you can kind of just scribble in, and that's good enough. All those points work. Now, if you checked and that point didn't work, that would mean that all the points on the other side would be a part of the solution. So you'd shade in the other side. So this is the answer to this problem, is this graph. You have a line and then you have a shaded in area to the right of that line. All right, so let's try one more of these together before you try one on your own. So again, we're just going to pick 2 points, and I'm going to let x be 0. Then 0 is greater than negative y, and divide both sides by negative 1, and you get 0 is equal to y. So that point is 0, 0. And now I'm going to try x is equal to 1. So then you get then you get 1 is greater than negative y. And again, divide both sides by negative 1. And you don't really need to worry about flipping the inequality. That's not really what we're doing here. In fact, you probably could just use equal signs here. You don't really need inequality signs. So we have 1 and negative 1. So those are our 2 points, 0, 0, and 1, negative 1. Again, we're just graphing the line. We don't really care about the inequalities at this point over here. This is not about inequalities over here. This is just about graphing the line. So you could choose equal signs. It doesn't really matter what you choose. We're going to go ahead and graph the line. So we have 0, 0, and we have 1, negative 1. Now, this inequality is not an equal to sign. On 37, we had a less than or equal to symbol. But in this problem, it's not equal to. It's just greater than. So what that means is we cannot draw a full line. We have to draw a dotted line, because what that means is that our solutions are not going to be on the actual line. They're going to be on one of the other sides of the line. So you just keep that a dotted line. So again, it's very simple. When you have a equal to, greater than, or less than or equal to sign, then it's going to be a full line, as you see here. But if it's not equal to, it's going to be a dotted line. All right, so now we do our check point. So I'll write check here. And let's try, we have to try a point that's nowhere near the line, because if you get too close to the line, you might go over it without knowing. So let's try 3, 0. And I'm going to make a purple color for the point that we checked, and make the check purple so we know what's going on here. All right, so I'm going to check with this point here. So that point is 3, 0. So now x is 3 and y is 0. So I just plugged in 3, 0 because that's the point that we're checking. You tell me, is 3 greater than 0? Because if we simplify that, we get 3 is greater than 0. So is that true? If you said yes, it's true, then you're correct. So what we do is we shade in this region. And that graph that you see there is the answer. So all of these points, I just want to make it clear, all of the points over here will work in this inequality. For example, if you plug in, let's see, 2, 2. 2, 2 would be about here, right? So if you plug that into this inequality, you get 2 is greater than negative 2. Is that correct? Yes, it is. So that works. All of these points in this shaded region will work in that inequality, so they're solutions to the inequality. Well, they're not really solutions, but they work in the inequality expression. All right, so this is a slightly more difficult problem, but since you've already done these types of algebra, you can probably do this on your own. So go ahead and try this one on your own, and when you come back, we'll do it together. All right, we're back. So again, we need to graph the line. So we'll let x is isolated, so we want to plug in the y values first. And I'm just going to write equal signs just so I don't confuse you here. So 2 times 0 minus 1, x is equal to negative 1. So we have negative 1, 0 is 1 point, and then let's let y equal 1. X is equal to 2 times 1 minus 1. And then we get 2 minus 1 is 1. So our point is 1, 1. And so negative 1, 0, and 1, 1, and connect the dots. And this is an equal to, greater than or equal to, so it's going to be a full line. So now we have to figure out if we're going to shade on this side or on this side. We don't know. So we're going to do a check. Just make sure that when you do a test point, make the point far from the line. So I'm going to choose all the way down here. Actually, I think I'll just choose this point again. Actually, no, I think I'll try this point. So test point. I should be titling those test point instead of check. Makes more sense. So now that point is 0, 3. So we plug it into the inequality. Again, I just plugged in 0 for x and 3 for y. And so simplify that. 2 times 3 is 6. And 6 minus 1 is 5. So you tell me, is 0 greater than, I didn't put my equal to there, is 0 greater than or equal to 5? Is 0 greater than or equal to 5? Well, obviously that's not true. It's not correct. So you don't shade in the region with that test point, you shade in the opposite region. So this region here. All right? So if you shade it in that region, good job. All right, so on to number 40. So try number 40, and when you come back, we'll do it together. All right, we're back. All right, so x is solved for, so we're going to plug in 0 for y. I'm just going to use equal signs. So x equals negative 4. Now we're going to plug in 3 for y. And we get negative 3. All right, so we're going to have to change the scale. So I'm going to use 6s. And negative 4 is 0. Negative 3, 3. And connect the dots. But when you connect the dots here, we don't have a less than or equal to sign. It's only less than, so we have to use broken dots. All right, now we have to do a test point. So let's try 0, 0. That's going to be an easy one. So plug in 0 for x and 0 for y. So 0 over 3 minus 4 is less than 0. We have to see if that's true. So negative 4 is less than 0. Is that true? It is true. So that means the purple dot is part of the solution, and all other dots on this side of the line are part of the solution. Now again, if that didn't work, that would just mean that you would color in the other side of the line. So again, all these points will work, all these points in here will work in this inequality. That's what that means. But because the line is a dotted line, the actual points on the line will actually not work. Because the points on the line will make these two values equal to each other. This value will be equal to this value, but it can't be because this says it can't be equal to. It just has, the left side has to be less than the right side. All right, so let's try 41. Go ahead and attempt number 41, and when you come back, we'll do it together. All right, we're back. All right, so I'm going to plug in 0 for x. And again, you can use whatever you want here. I'm just going to use equal signs. So y equals -1. So we have 0, -1. And now I'm going to plug in 0 for y, because they just work. Makes it easy to simplify. So x is equal to -1. So we have 0, -1, and -1, 0. -1, 0, and 0, -1. And this isn't less than or equal to, which means we need a bold line, not a dotted line, a full line. All right, so now we have to do a test point. So I'm going to test something all the way over here. So now we test. We're just trying to figure out, do we shade on this side or on this side? That's what we're using the purple dot for. So I'm going to test. So that point is 3, 3. And I should probably put the points that I'm testing here. 0, 0. So this point was 3, 0. And this point was 0, 3. So 3, 3. So let's test that. So 3 plus 3 is less than or equal to -1. I just plugged in 3 for x and y. So now we get 6 is less than or equal to -1. So is it true that 6 is equal to or is less than or equal to -1? That's not correct. So because it's not correct, you're going to shade in this region over here. And that's your answer. The graph is your answer. All right. So let's try number 42. Go and attempt that one, and when you come back, we'll do it together. All right, we're back. And let's try, x is solved for, so we're going to plug in y. Let's try 0 for y. So x is equal to 1. The point is 1, 0. Now let's try -1 for y. And we get x is equal to 0, so the point is 0, -1. And go and graph those, 1, 0, and 0, -1. Now this is not an equal to, it's less than, but not less than or equal to. So we have to do a dotted line. That line really isn't very good. Let's try that again. Whoops. Doesn't have to be perfect. All right, so now we have to do a test point. I'm going to test, and it's going to, make sure your point is far from the line. You don't want to accidentally plug in a point on the other side or on the line. So that point is -3, 3. So I'm going to do a test over here. I'm going to plug in negative 3, 3. 1 plus 3 is less than negative 3. So I plugged in the x value here and the y value here. All right, so now we have to see if that expression is true. So 1 plus 3 is 4. 4 is less than negative 3. Is that correct? No, it's not correct. If you said no, you were correct. So because it's not correct, we shade in the other side. And that's the answer. All right, see if you can do number 43, and when you come back, we'll do it together. All right, we're back. So we graph our 2 points. X is isolated, so it's easiest to choose a y value first. So we'll choose 0 for y. And again, we can just use equal signs here. We don't really need the inequalities. So we get x is equal to negative 1, and our point is negative 1, 0. Now let's choose 1 for y. And we get 1, 1. So let's put those points in our table and plot them. Negative 1, 0, and 1, 1. And we have less than or equal to here, so we can make a full line. And now we have to do a test point to figure out which side of the line we are going to shade in. So let's do 3, negative 1. We're going to test that point. And if the point works in this inequality, then we're going to shade in this region. If it doesn't work in this inequality, then we're going to shade in this region. So we're going to plug that point into the inequality. So we're going to plug both the x and y. So we have negative 1 plus 2 times the y value is negative 1 here. And that's supposed to be less than or equal to x, and x is 3 for our point. So if we simplify this, we get negative 3 is less than or equal to 3. So the big question is that correct? Is it true that negative 3 is less than or equal to 3? Well, it is less than, so it works. So we shade in this side of the graph. So if you got that graph, if that was your answer, good job. All right, try number 44, and when you come back, we'll do it together. All right, we're back. So y is isolated, which means it's easier to choose an x value first. So let's choose x is 0. And we have y is equal to negative 1. So the point is 0, negative 1. And now let's choose x is equal to, let's see, we want to stay in our window, so let's choose negative 1. So negative 3 times negative 1. And we get y is equal to 2, so our point is negative 1, 2. Let's put those in our table. Again, you don't really need both the table and the points. You really only need one or the other. But I'm just showing you the table so you can see what it looks like, because that's used very commonly. 0, negative 1 is here, and negative 1, 2 is here. Now, in this case, we don't have a greater than or equal to symbol. We only have a greater than symbol, so we have to use a dotted line. Now we have to do a test point to see which side of the line to shade. Let's choose 2, 2. doesn't really matter what point you choose as long as it's very, very far from the line. So now we have negative 3 times 2 minus 1 is greater than 2. Again, I chose these values for x and y, 2, 2. I'm going to label that. So now we get negative 6 minus 1, and negative 7 is greater than 2. So is negative 7 greater than 2? It is not. So we shade the other side. All right, so if you got that graph, good job. All right, so that was the class. We don't really have much more time here. So go ahead and take screenshots of all those problems that we did. This is all the work that we did for today. So take a screenshot of the first page, and this will help you. With your homework, and also to help you study for tests. And you don't have to take screenshots of all these pages, but you can if you want to see all the work that we did. And we skipped some of those problems, as you can see. And let's go ahead and look at the homework. So here's your homework. Take a screenshot of that. And you're probably wondering, where's the answers? Well, the answers are right here. Take a screenshot of this. And take a screenshot of this. And do the homework completely and correctly. I want you to, you're going to have to draw your axes, just like you see them drawn here. You're going to have to label your axes x and y, write the original equation, circle your problem numbers, and your shading doesn't have to be this good. It just has to be as good as we did in class. And so make sure that you do it completely and correctly, and I'll look forward to seeing you in the next class.